Good evening, students. So yesterday we are talking about LR parses, LR0 parsing, and in that LR0 parsing, to construct LR0 parse table, so we need to do some steps. So in yesterday's class, I discussed what are the steps we need to do to construct LR0 parcel. So the first step is construct augmented grammar. Construct augmented grammar. And second step is identify or construct LR0 items DFA with the help of closure and goto function. With the help of closure and goto. And finally, with these, we can construct the table for LR0 parcel. So construct the parse table. Once again, I will explain you how to construct the augmented grammar and how to construct LR0 items for the given grammar with the help of closure and goto. Then we will do some examples. Yes, sir. Suppose if the grammar is S derives, open parenthesis, S and closed parenthesis, and S derives small a. So for this grammar, the augmented grammar means we need to just add one more production. We need to just add one more production for the given grammar. The given grammar is S derives, open parenthesis, closed parenthesis, and S derives A. For this given grammar, I am adding one more new production. The new production is S dash derives S. S dash derives S. So the importance of the augmentation grammar or augmented grammar also I reveal you. So here if you take S is the start symbol, here S is start symbol. So here only with S we are having two productions. Suppose at what time we have to say that is accepted. So that is the problem. To tell the acceptancy of the string. So we need only one symbol that for the start symbol. So for that purpose, we are taking new start symbol. So augmented grammar, in augmented grammar, we are adding new production. In that new production, with the new symbol, we are deriving the start symbol. So the purpose of the new symbol is sometimes in our grammar, more than one production maybe exist with the start symbol. At that time, we cannot say the grammar is accepted or not. For that purpose, every time the start symbol of the production should be unique and that should be 1. So for that purpose, we are taking new symbol. Sir, if there is a grammar look like this, that means more than one production is there with start symbol, then only it is required to take augmented grammar. No, sir. For every grammar, we need to construct augmented grammar. Even though there are more than one production with star symbol or not, that is not the criteria. But the purpose is that. But the purpose is that one. Next one. So next we need to construct LR0 items. LR0 items DFA. So for constructing LR0, we are using closure and goto. Sir, what is closure? Closure means, suppose if any production is in the format of A, S derives A dot B, S derives A dot B. At that time, we need to add the B productions. We need to add the B productions to the S. For example, S derives A, B, and A derives small a, and B derives small b. Here the B production is this one. This production has to add to this one. So this item or this state. So that is nothing but closure. That is nothing but closure. Suppose if we take E derives E plus T, and E derives E plus E. Take E plus T only. So, and E derives N. Here E derives dot E plus T. After dot, we are having the non-terminal. That non-terminal is producing another production. So we have to add that production to this item or this part. So for that purpose, we are calling this one as closure. Closure is nothing but adding the B productions to the item. B productions to the item. Sir, what is goto? Sir, what is goto? Goto means moving the dot symbol towards right. Moving the dot symbol towards right. Suppose this is the closure. So here closure is completed. So for this, S derives AB dot and B derives B dot. Like this, we need to move the dot symbol towards right. So that is nothing but goto. So by completing and by doing all these, closure and goto for all the productions, then the LR0 items are completed. Then the LR0 items of DFA is completed, sir. So we will see for the we will see the example for this one, sir. So for example, if you take the same example, S derives open parenthesis S derives small a. So the augmented grammar for this one is S dash derives open parenthesis S, and S derives sorry sir. Augmented grammar is S dash derives S. That is the new production. So the existing grammar is S derives open parenthesis S closed parenthesis, and S derives small a. So this is the augmented grammar. For this augmented grammar, we need to construct LR0 items. LR0 items. For LR0, for doing LR0 items of DFA, we need to construct or we need to use closure and goto. Otherwise, we need to perform closure and goto. So how we are performing closure and goto, we will see. So take a first production. So the first production is S dash derives dot S. We start at the initial state, that is S dash derives dot S. After dot, we need to check after dot what is the symbol. Is it the non-terminal or terminal? Is it the non-terminal or terminal? Suppose if it is non-terminal and is producing any other production, that production has to include to this. So here S is producing another production, that is S derives S derives dot open parenthesis S. Sir, why we add this production? Because S dash derives dot S. After dot, we are having non-terminal symbol, and that non-terminal symbol is producing the production. So we need to add those productions to this one. So for that purpose, we added this one. So like this, S is deriving one more production, that is S derives dot A. S derives dot A. Here, this S is deriving two productions. Those two are added to this. But here, after dot, it is parenthesis. So that is not the non-terminal. So we don't consider about open parenthesis. So after that, in this production, the after dot, we are having terminal. So no need to check for the remaining productions. So this is the thing. So we are giving the name for this one as I0. I0. And this is the start state. This is the starting state. So after completion of this one, closure is completed. Closure is completed for this item. Closure is completed for this item. Now we need to perform go to. We need to perform go to. What is go to? Go to is nothing but moving the dot symbol to right or towards right. So that is nothing but go to. So here we need to move the dot symbol. For example, take S. S dash derives S dot. So in this production, I am moving dot symbol towards right. So after that, I got this one. Is there any non-terminal after dot? No, sir. So just leave it. So this is another state. After that, so here we are having this production. For this production, we have to write S derives open parenthesis dot S closed parenthesis. Here also I moved dot towards right. So after that I got this production. So now we can call all these are not a productions, LR0 items, because if any production having dot on the right hand side of the production, those productions are called as LR0 items. So this is LR0 item. So here after dot we are having non-terminal. So the non-terminal is S, and S is producing two more productions. What are those two more productions? S derives dot open parenthesis S closed parenthesis, and S derives dot A, So these are the productions derived by the S. So this is completed. So closure for this, go to for this one is completed. Go to for this one is completed, as well as closure for this production is also completed. Here next, S derives A dot. So dot is reached to the end. After it reached to the end, the closure item has completed or finished. So no need to move, sir. No need to move. Here I cannot move, and here there is a chance to move. So again move. S derives open parenthesis S dot closed parenthesis. Suppose if we see here, only terminal existed after dot, so we can't do further. That means we can't add more production. We can't add more productions, or closure is not possible. So coming to here, so this one is looks like same as this one. So I0 is I0 second production is same as looks like. So for the purpose, so we are moving when S derives dot open parenthesis S closed parenthesis. So we are moving from I0 to this one. So suppose if any number of times, if the same production comes, so we can perform here itself. We can perform here itself. So next, suppose S derives dot A. Suppose in I0, S derives dot A came, so that is moved to this state. So suppose if you get S derives dot A, you can move to this one, sir. You can move to this one. Okay. So this is completed. This is completed. This is also completed. And go to and closure, everything completed for this. So now coming to here, S derives open parenthesis S dot. So for go to, it can be written like this: S derives open parenthesis S closure parenthesis dot. Is there any possibility for the closure? No, because after that there is no symbols. There is no symbols. For that purpose, there is no possibility for the closure. Sir, every time first we need to check for the closure. If the closure is not possible, then only we move to the go to, sir. Then only we need to move to the go to. So after completion of all these things, so our work has been finished. So completely our work has been completed. So now how we construct the table? So augmented grammar is completed. Construction of augmented grammar is completed. Identification of or construction of LR0 items DFA is also completed. So now we need to construct the parts table. Sir, how we need to construct the parts table for this one? So we already discussed it. So the parts table is two parts. One is action part, another one is go to part. One is action part, another one is go to part. In the action part, we need to add all the terminals. Sir, what are the terminals available here? Open parenthesis, A, closed parenthesis, and dollar are the possibilities and are the terminals. And coming to the non-terminals. Sir, what are the non-terminals in the given grammar? Only yes. Sir, it is not required to consider the S dash. So that is augmented, that is added by us. So that's why it is not required. We need to take from the given grammar. In the given grammar, only one non-terminal is there. That is yes, sir. That is yes. So now, so this is the format. For the purpose of the states, you please come back. So here I0, this is I0, this is I1, this is I2, and this is I3, this is I4, this is I5. So initially the state is I0, next I1, I2, I3, I4, I5. So there are 6 number of states are there. So one is starts with I0, I1, I2, I3, I4, I5. So I0, I1, I2, I3, I4, and I5. So these are the states available, sir. Okay, right. So we need to fill these. Now we need to fill these things, sir. So now we will check. So how we need to fill this? Yes, sir. So coming to the I naught, please come back, sir. Coming to I naught. So when dot came after S, when dot came after S, we are moving to I1. We are moving to I1. So before going to this, I will write a small thing here. So the thing is, suppose after dot symbol, there may be a chance of terminal, there may be a chance of terminal, there may be a chance of non-terminal, there may be a chance of non-terminal, and there may be a chance of there is no symbol. There is no symbol. That means LR item completed. That means LR0 item completed. So what I am telling is, so after dot, sometimes there may be a terminal. Here, suppose if you take this production, after dot there is a terminal, and sometimes that may be a non-terminal. Suppose if you take here, that is a non-terminal, and LR0 item completed. Suppose if you take this, the dot came to end. So that means the LR0 item is completed. So these are the three cases majorly. So for these three cases, what I am telling is, so suppose if it is a terminal, that is the shift action. Suppose if it is the terminal, after that, if there is a terminal, that is the shift action. Suppose if the after the dot, the symbol is non-terminal. Non-terminal means capital letter. That means go to action. That means go to action. Suppose LR0 item is completed. That means reduction. Or reduce. So now we will see. After that, what is the symbols are here? That is the non-terminal. So that is the non-terminal, and where it is moving? It is moving to item 1. Item 1 means state 1. So here we are having non-terminal. So and that is moving to item 1. So I naught on S, that is 1. And next, come back. I naught, and after that, here we are having open parenthesis. I naught, after that we are having open parenthesis. So here we need to write, after that there is a terminal, and it is moving to I2. So what we need to write? That is a shift. And has to move to I naught on open parenthesis, that is moving to I2. So that's why we need to write shift to. Suppose if it is the terminal, we have to write shift. Suppose if the non-terminal, we have to write go to. That means numbers, state numbers. So now we will see. So after I naught on small a, that means here it is small a. After getting small a, it is moving to. After getting small a, it is moving to I3. So that is state 3, and this is a terminal. So I naught on small a, that is S3. I naught on small a, that is S3. So okay, good. Next, come back. So with this state, with all inputs, that is completed. Next, I1 S dash derives S dot. So this means this is completed. This production is completed, or LR0 item is completed. What he informed, if LR0 item is completed, that is reduced. That is reduced. But this production is not available in the given grammar for the reduction. Sir, what we have to do? So suppose if the production starts with start symbol, that has to be written like accept. That has to be written like accept. So I1 with dollar, I1 with dollar accept. Sir, how can you say the dollar, sir? How can you say the dollar, sir? So after the end of the input for the start symbol, so we are having the dollar. So for that purpose, we are writing at the place of dollar at I1, that is accept. That is accept. And next one, I am at I2, that means state 2. I am at I2, that means state 2. So here, after dot, there is yes. After dot, there is yes. So that is moving to I4. That is moving to state 4. So that's why I2 on yes, I2 on yes, we need to write 4. So I2 on yes, that is 4. I2 on yes, that is 4, sir. And the next one. So I2 on open parenthesis. I2 on open parenthesis. I2 on open parenthesis. So that is staying there itself. That is staying there itself. So that's why I2 on open parenthesis, it is remains at I2. That means state 2. So we need to write. So we need to write I2 on open parenthesis. It is staying at S2, the same state. After that, S derives dot A. Here it is the terminal. Here it is also the terminal. That's why we have written S2. Here it is also the terminal. Here it is also the terminal. So S derives dot A. That means I2 on A. I2 on A. It is moving to. It is moving to I3. It is moving to I3. So we need to write. We need to write I2 on A. It is moving to. It is moving to I3. So that's why that is the state 3. State 3. So these are all also completed. Next, coming to I3. Coming to I3, the production has been completed, or LR0 item completed. So for example, if it is completed, what we have to do? So we will check it one. We will check it later, sir. So reduction items we will check it later, sir. So after that, in I4 there is a shift. There is a shift because after dot there is the terminal. There is the terminal where it is moving. Where it is moving? So it is moving to I5. That means I4 on closed parenthesis. I4 on closed parenthesis. It is moving to state 5. It is moving to state 5. It is moving to state 5. So this is the thing, sir. This is the thing. Next, coming to this one, it is completed, and this is also completed. So you please come. Suppose if any production or any LR item is completed, that has to be reduced. Sir, how we have to reduce? And one more question is, so where we have to put the reduction symbol or reduced symbol? This is the item 3, that means state 3, and this is the item 5, that means state 5. So for that purpose, for the reduction, what we have to do is, take all the terminals. The terminals are closed parenthesis, A, open parenthesis, A, closed parenthesis, and $. So for I3, there is a reduction, and for I5 also there is a reduction. So all the boxes or all the cells of the terminals should be filled with R3, sorry sir, R2, 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 R1, 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 R1. Sir, why you have written R2, 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 R1, 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 R1? So once you please come back, sir. So here I am reducing the grammar production. That is the second production. That's why I am giving R2. That's why I am giving R2 for I3. And suppose if you come here, the production is 1. So that's why we are giving the name to this one is R1. So finally, we have to fill all the terminals with reduction symbol. So what is the reduction symbol? For I3 that is R2, and for I5 that is R1. So R2, 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 R2. And for I5, R2, sorry sir, R1, 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 R1. So this is the thing, sir. This is the way for the constructing parse table. So, but you don't worry, sir. For every problem, it is not required to construct the parse table. Suppose if it is academic examination, you need to write the parse table for every problem. But for the GATE examination, you no need to write a parse table for every problem. But I explained everything. Once again, if you are having any doubt, again I will explain you. But you may think, sir, it is taking a lot of time. Sir, how can we solve these kind of problems in GATE? So, because that is a time-bounded examination. So, for that purpose, I am telling you no need to construct the parse table for every problem. With the construction of DFA itself, we can say that the how many number of shift operations are there, and how many number of reduction operations are there, and how many number of accept operations are there, and how many number of go to operations are there, So without seeing the table, we can write. Without seeing the table itself, we can write. So we'll check it once. How many number of shift operations are there, sir? So here it is go to operation. So this one, and this is the shift operation. So this is 1, this is 2, S2. Sir, the meaning of S1, S2 is shift operation 1, shift operation 2, like shift to OP 1, shift to OP 2, and here it is accept. So that is different. And here it is after dot S. So that is 2. So here we can say that for go to there are 2 operations. For go to are 2 actions or 2 operations. 2 actions performed for go to. Coming to shift, there is 1, 2, and here it is reduction. So next, here it is 3, and here it is 4, and here it is 5. Here it is 5, sir. So shift operations are 5. Shift operations are 5. Sir, how many number of reduction operations are there, sir? So you may think there are 2, sir. So for this production 1, and for this production 2, that is 1 and 2, sir. So no, sir. So for this you need to construct the table like I3, I5. How many number of terminals are there, sir? 4 for open parenthesis, A, closed parenthesis, and $. So for every terminal we have to place R1 or R2, 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 and R1, 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 R1. So how many number of reductions are there, sir? 8 reductions are there, or 8 reduction operations are there. Sir, what I am telling is, here there is a reduction operation, and here there is a reduce operation. Reduction or reduce, both are same, sir. Don't feel it is different. So here it is a reduce operation, here it is a reduce operation. Here it is at I5, that means state 5. Here it is at I3, that means state 3. So we need to place the reduce operation for all the boxes of terminals at that state. That means I3, we are having terminals, open parenthesis, A, closed parenthesis, dollar. 4 terminals are there. So 4 reduce operations are there. For I5 also, same kind of terminals. So 4 terminals. For 4 terminals, 4 reduction operations. So we can say that reduce operations are 8, sir. Reduce operations are 8, sir. How many acceptance operations, sir? Only 1. Accept operation is only 1. So this is the final state and this is the accept. So accept operations are only 1. So that is the final state. So this is the way to find how many number of shift operations, how many number of reduce operations for the given grammar with the help of LR0 items. Without giving the table. Suppose in the previous examples yesterday we saw some problems. In those problems, he has given the grammar, he has given the table, and he has given the string. For this, he has given the grammar, and he is asking us how many number of shift operations are there, how many number of reduce operations are there, how many number of go to operations or actions are there, and how many number of acceptance are there for that parse table, not for the string. After construction of the table, we can identify easily the number of reduce operations or actions and the number of shift actions for the given string acceptancy also. So without seeing the table, we have written all this. Suppose if you see the table, here how many number of shift operations are there, sir? 1, 2, 3, 4, 5. So shift operations are 5. How many reduce operations are there, sir? 1, 2, 3, 4, 5, 6, 7, 8. So the reduce operations are 8. How many go to operations, sir? 1, 2. So go to actions or go to operations are 2. And how many number of accept actions are there? Only 1. So accept, for specifying the accept or for telling accepts, only 1 action is there. So total number of actions for the table are 16. Total number of actions for the table are 16. So this is the way for constructing LR parsing table. This is the way for constructing LR parsing table. So almost it took 40 minutes for constructing of LR parsing table, but you please don't worry. So we can write the number of shift actions, number of reduce actions, number of go to actions, as well as number of accept actions within 5 minutes. Within 5 minutes or less than 5 minutes. So for every problem, it is not required to write the table. Without table, with the help of DFA, LR0 items DFA, we can do all these things. It is not required. So it is no need to construct the parse or LR0 parse table every time. It is not required to construct the LR parsing table. Sir, without writing LR parsing table, so how can we say the number of shift operations, number of reduction? So here itself I told you. So after dot symbol, If there is a terminal, that is the shift action. If there is a terminal, that is the shift action. And if that is the non-terminal, sir, how can we find the terminals and non-terminals? So in the formal language and automata theory, you may see, and in comparative design also, many number of times we used terminals. All terminals are special symbols and small case letters, and the non-terminals are capital letters. Non-terminals are capital letters. Other than these two, so it may move to end of the right hand side production. So for that purpose, that is LR0 item completed. That is for reduce. That is for reduce. Other than these three, there is a production. The production is the left hand side of the production is a start symbol. That start symbol production is written as accept. Is written as accept. So this is the way, sir, for finding the number of shift, number of go to, number of accept, and the number of reduce operations. So here you need to concentrate on here clearly, sir. So for reduce operations, for that item, you need to fill all the terminal places. For reduce action, you need to fill all the terminal places of that state. So this is the thing, sir. So if anyone are having doubt for construction of LR0 table or parse table, you may ask, sir. So I will explain once again, or I will clear your doubts. Then I will move forward. If anyone are having doubt for constructing the LR0 parse table, so you can ask. For construction of LR0 parse table, first you need to construct the augmented grammar. Augmented grammar means we need to add the new production. Then we need to construct the LR0 DFA, LR0 items DFA. Sir, we are not constructing the DFA for the grammar. We are constructing the grammar for the LR0 items. We are constructing the DFA for the LR0 items. LR0 items means states. LR0 items means states. For states, the number of states are finite for any LR0 items. So for constructing LR0 items, we are using two. One is closure, another one is go to. Closure means if the production is in the format of S there is A dot B, we need to add B productions if any are producing the other productions. So then we need to add them to that closure or that item. Otherwise, go to, coming to the go to, we need to move the dot symbol towards right. So that is the thing, sir. So if anyone are having doubt, you please ask, sir. So this is very important, sir, and we are getting the questions on this one. So for finding the number of actions and shifts, like, so if there is any ambiguity, you please ask. What you see, sir? Is it a Telugu cinema or Hindi cinema? Suppose if it is a Telugu cinema, you may have doubts. Suppose if it is a Hindi cinema, you don't have any doubts because nothing understand. Yes, sir. Without if anyone asking doubts, I cannot understand your doubts, sir. So that's why I am moving forward. So if anyone are having doubts, you can ask at the end of the class also. So here, if you are having the clear idea about the concept and algorithm, you can easily score the marks. Otherwise, it is very difficult. So the subject is very easy, sir. Comparative design subject is very easy. Definitely, I can say again, it is very easy. Till now, we have discussed so many number of topics. So everywhere we are giving clear idea how to find the tokens. So we are having some steps, some algorithmic steps. So not only procedure, there is an algorithm. Algorithm name itself, the finite number of steps, how to perform the task step by step. So in that criteria, here we are telling, so the algorithm, how we need to accept the string, how we need to find the tokens, how we need to find the handle. So don't forget that about the terminology also, sir. What is handle? What is RMD? What is LMD? What is the syntax tree? What is a parse tree? What is the purpose of the parser? So all these things you have to keep in mind. So because everywhere I am using the parse tree and LR0 items, syntax tree, context tree grammar, and all these things. So I am using, sir. So for the next few classes, that means almost next further 2 weeks also, I will use this terminology only. So for that purpose, please keep it in mind. So the terminology, the definitions, and the meaning and is very important. Meaning is very important for attempting compiler design questions. So okay, next one is the given grammar is LR0 grammar or not? So next questions are another kind of questions. There may be a chance. Not only there may be a chance, sir. There are many chances are there. So many number of questions asked, many number of times asked question on this area. You please listen, sir. LR0 grammar or not? The given grammar is LR0 grammar or not? The given grammar is LR0 grammar or not? Sir, how can we say the grammar is LR0 grammar? Sir, how can we say the grammar is LR0 grammar? Right, sir. Any LR parsing table, any LR0 parsing table, any LR0 parsing table contains shift, reduce, or reduce in a single box, or cell, then that is not LR0 grammar. Very simple, sir. So what I am telling is any parse table, what parse table it is? LR0 parse table. Sir, how many number of bottom-up parsing algorithms are there, sir? LR0 parsing algorithm, SLR1, CLR1, and LALR1. In that, this is the first algorithm we are discussing. For this, we checked how to accept the string using shift reduce parsing. In shift reduce parsing, there is a problem. That is a shift reduce conflict and reduce conflict. For that purpose, we move to LR0 items. With the LR0 items, manually we checked, and the algorithm with the algorithm also we checked. When the table is given and when the grammar is given and the string is given, we checked. And now we are constructing the table for the given grammar. So up to now we constructed the tables. Then now the question is, the constructed LR0 parse table contains is shift reduce or reduce in a single box. Sir, what does that mean? So for example, if you see here, there is a problem here because it is having reduce and shift in the same box. So this is not LR0 grammar. LR0 grammar. This is not LR0 grammar. This is LR0 parse table. This is LR0 parse table. That is okay. But it is not the LR0 grammar. If any LR0 table is the LR0 grammar, that should be satisfied. Every cell of the parse table should have unique action. That may be a shift, or that may be a reduce, or that may be a blank, or that may be a state. That's it. Suppose if any shift reduce combination or reduce combination is filled in a single cell, suppose if you take this cell, there is a R1 and R2. So what you have to perform at the state I4 and at the dollar? So there are two choices. So one is R1, another one is R2. So you can reduce production 1, you can reduce production 2. So which production has to be produced as per the rule? So we don't know. So that's why that is the conflict. If there is a conflict, that is not the LR0 grammar. In any LR0 parse table contains shift reduce or reduce in a single cell or single box, then that is not the LR0 grammar. So simply we can say that LR0 parse table should not contain multiple entries. Suppose if there is a multiple entries, that is not the LR grammar. There is no multiple entries. That is LR0 grammar. The multiple entries means shift reduce or reduce. Mainly shift reduce or reduce. So this is the thing, sir. So you may ask again, sir, when we get, or how can we know there is a shift reduce thing? Because I told you, no need to construct a table. Sir, how can we find without constructing the table? There is a shift and reduce in the single cell. Okay. If any item is having the production looks like A derives alpha dot small a x and B derives y dot. So these are the productions in some item. That may be a I0 or I1, I2, I3 or any item. There is a productions like this. So coming to these productions. So after that, there is a symbol that is a terminal. So if any production after that there is a symbol that is a terminal, we can say that is the shift action. So here it is a shift action is there. And coming to B production, this is ended. If any production on the right hand side is ended with the dot symbol, we can say that reduce. So in this case, we can say that there is a SR conflict. Please listen carefully, sir. Very, very simple things I am telling and explaining. So if you pay the concentration, it is very easy to answer the questions. So once again, I am telling, sir, how can we find SR conflict? Suppose if any item, that may be item 0 or item 1, anything, it may have more than one production. So more than one productions in any item may have. So at that situation, one production is in the format of like this, another one production is format of like this. So in this case, After that, there is a terminal. So I explained you the thing. So after dot, if there is a terminal, that is the shift action. So this is the shift action. And after, dot came to end. That is LR0 item completed. Dot came to end of the production or end of the right hand side string. So we can say that that is completed. So we can say that. So this is the reduce. In one item, there are two actions. Or at one state, item means nothing but state. At one state, we are doing one reduction as well as one shift. What we have to do? Reduction means pop, shift means push. So which operation we have to do? We don't know. So that is nothing but SR conflict. And another case. What is reduce operation, sir? Suppose there are two productions. A derives X dot and B derives Y dot. So this production is ended and this production is also ended. If any one production is ended with dot, so that is a reduction. And here it is also reduction. If any item having these kind of productions, that is the reduce conflict. So by seeing the DFA states or items, we can say that is there SR conflict or is there RR conflict. SR conflict means shift reduce conflict. RR conflict means reduce conflict. Suppose if there is a SR conflict or RR conflict, we can say that that is not the LR0 grammar, not an LR0 item. That is not the LR0 grammar. So, sir, how many number of grammars are there? For every parsing algorithm, we are having grammar. That means for LR0, we are having grammar. For SLR1, we are having grammar. For CLR1, we are having grammar. And LALR1, we are having grammar. So for every algorithm, we need to check it, sir. So, okay, hope you understand it, sir. The definition, any LR parsing table contains the shift reduce or reduce in this single box. That is not the LR grammar. So how can you say that shift reduce problem is there or reduce problem is there without seeing the table? By seeing the item itself, we can say that there is SR conflict or there is RR conflict. Sir, how can you say, sir? So here, if the grammar is in this format, we can say that SR conflict is there. Suppose if the grammar is in this format, we can say that RR conflict is there, sir. So we will move to the problem. The following grammar is LR0 grammar or not? Is the following grammar is LR0 grammar or not? Yes, sir. It is a simple thing, sir. So we discussed everything. So it is the 2-3 minutes time to find the grammar is LR0 grammar or not. So the given grammar is E derives T plus E and E derives T and T derives small a. So what we have to do? So for every given grammar, first we need to write augmented grammar. Augmented grammar is E dash derives E. Just add the new production. You don't take it a complex. So just add the new production. E dash derives E and E derives T plus E and E derives T and T derives small a. So this is the augmented grammar. So for this segmented grammar, we need to construct DFA of LR items or LR items of DFA. So we take it. So E derives, E dash derives E, and E derives T plus E, and E derives T, and T derives small a, and T derives small a. So this is item 0. Sir, when it is item 0, so after completion of closure. Sir, how can you say this is closure? So all the things we need to add this item 0 or not. How can we say, sir? Just wait, sir. Yes, sir. Now, so initially take the start production. E dash derives dot E. E dash derives dot E. After that, after dot, what we are having? Non-terminal. So suppose if it is a non-terminal, again we have to add those non-terminal productions. How many number of non-terminal productions are there, sir? With E, there are 2 productions are there, sir. So we need to add those 2 productions. Dot T plus E, and E derives dot T. So here dot, after dot, what we are having? T, sir. What we are having? T, sir. So with T there is a production. With T there is a production. So we need to add dot A. We need to add dot A. Sir, here also there is a production. E derives dot T. Is there a required to add T derives dot A again? No, sir. So if this once it is added, so it is not required to add once again. It is not required to add once again. Now, so closure is completed. Now move to go to. So go to operation is E derives E dot. We are moving the dot symbol towards right. We are moving dot symbol towards right. So the dot symbol came to end. So no need to add other productions to this item. This is I1. This is I1. So coming to here. So there is a production E derives dot T, and here also E derives dot T. So with T we are having 2 productions. Those 2 productions has to add in a single one. So for that purpose, E derives T dot plus E, and E derives T dot. E derives T dot. Sir, sometimes we no need to do the total question to say the answer. No need to do the total question also. Here, what is the question for us? So is the grammar is given grammar is LR0 grammar or not? Suppose if any grammar is LR0 grammar, that has to satisfy one property. What is that property? So in any item, it should not contain shift operation as well as reduce operation. So suppose if you see here multiple operations are there. So multiple actions are there. So what is this? So this is the shift operation, because after dot we are having plus is the terminal. So this is the shift operation, and here it is reached to the end. So that means this is the reduce operation. So with this we can say that there is a SR conflict. So there is a SR conflict. So that is not the LR0 grammar. The given grammar is not the LR0 grammar. So for the purpose of the construction of table, you need to write all the items and all the closure operations and all the go to. But to find the LR0 items, it is not required. It is not required to write for remaining items. So here itself we can say that, sir, sometimes in the first item itself we can say that, in the first item it's we can say that there is a reduce or there is a shift reduce conflict. So for that purpose, for expansion of every item, we need to check, is there any shift reduce or reduce conflict? So here there is a shift reduce conflict. That's why we can say the given grammar is LR, not a LR0 grammar. The given grammar is not LR0 grammar. So because here it is having shift reduce conflict. Sir, how can you say, sir? So here the production is there. After dot, there is a terminal. There is a terminal. Sir, don't forget it. Don't forget it. So for shift operation, after dot, we should have the terminal. We should have the terminal. For the reduction, the total string has to be completed and the dot symbol should be the end of the string, the end of the production or string. So in that case only we say that this is the reduction and this is the shift. So the shift and reduction both are in the same item, the item number 2. So that in this case we can say that the given grammar or LR0 grammar, sorry, the given grammar is not an LR0 grammar, not an LR0 grammar. Is it understood, sir? Is it clear? It is only one way, it is not two way, sir. No, sir, it is a full duplex. You can communicate at any time. Okay, we'll move to next problem. So check the given grammar is LR0 grammar or not. Is the given grammar is LR0 grammar or not? So this is the question, and the given grammar is S derives AA and A derives small a, capital A, and capital A derives small a. So this is the given grammar, sir. So for this we need to first write the augmented grammar. S derives, sorry, S dash derives yes, S dash derives yes, and then S derives capital A, and capital A derives sir. The previous question is previously asked gate question, sir. This is the previously asked gate question. So I'm taking from the previously asked questions only. So you please, if anyone are having doubt, please clear. Please ask and clear here itself. Okay. So S derives AA and A derives small a, capital A, and A derives small a. So this is the augmented grammar for the given grammar. This is the augmented grammar for the given grammar. Okay. So what we have to do? So what we have to do here? So here we have to do write the DFA for the LR0 items. Sir, how we write the LR0 items? First you take first production from the augmented grammar and put the dot initially, So after dot, we are having non-terminal, and that non-terminal is producing another production. So for that purpose, we need to add that production to this item. So S derives dot A. Here after dot there is again non-terminal. So that is A, and A is also producing small a, capital A, and A is again producing dot A. Sir, is there any reduce or shift? Yes, there is a shift. Shift is there. Small a. But shift is not a conflict. Shift is not a conflict. Our conflict is shift reduce or reduce. So with the LR0, sorry sir, with the I naught, there is no problem. With I naught, there is no problem. So next, move to go to. So in the go to, S dash derives S dot. So it is reached to the end, and this is the start symbol. So if it is a start symbol or any other symbol in any other state, it is not our criteria. So after it is reached to the end, we can't add the productions to this item. So this is I1. Next one is S derives A dot A. S derives A dot A. Here I am at I naught on A, capital A. Here yes, here capital A. I am moving to the another state. So at that time, so the production changed. One dot moved towards right. So now after that we are having non-terminal. So if there is a non-terminal, after that we need to add the remaining productions. What are the productions with A? So these are the two productions. So we need to add A derives A, and A derives dot small a. Is it completed or anything is required to add? No, sir, because only non-terminal is A. So with the non-terminal A, we are having two productions. We added those two productions. So it is completed. Now you please check, because there are more than one production is there. So this is the go to, and this is the shift, and this is the shift. So shift action is there and go to action is there. Sir, how can you say this is the go to? Because after that there is a non-terminal. After that there is a terminal. After that there is a terminal. So these are shift, these are go to. So there is no problem. So next, coming to here, A on A. Sir, here these two are I naught on A. It is moving to one state only. A derives A dot A. So here after that again there is a non-terminal. So you need to add A derives dot A and A derives dot A. After that you need to add this one. So this is A dot. So once again I will explain you, sir. You please listen carefully. So here what I am telling is, first if you take this production, for go to actions, we are writing A derives A dot A. This production is written like this. So for here, after that there is a non-terminal. Suppose if there is a non-terminal after A, that is the closure operation has to be performed and add those non-terminal productions to this item. For that purpose, I have added these two items here. So with this production, our closure action is completed. If you take this one, it is also taking small a and moving. Sir, here it is taking small a, here it is taking small a. Sir, we know about DFA. I think you are having a clear idea about finite automata. In finite automata, there are two. One is NFA, another one is DFA. Coming to the NFA, every state may have more one or zero or one or more than one transition. one transition. But coming to DFA, every state must have exactly one transition with the input alphabet. Every state must have exactly one transition for the input alphabet. Here the input alphabet, that means the terminal is A. So with A, we should not go to two states. With that A, we need to move to only one state. That's why this is the totally one state. This is the totally one state. With this, A derives A dot, because for go to it is moved. So suppose if you see here, so it is the non-terminal. Non-terminal means go to. Non-terminal means go to. It is the terminal. Terminal means shift. It is also the terminal. That means shift. It is ended. Ended means reduce. Ended means reduce. In this single item, in any item, there is a shift and reduce. Both are existed. In any item, shift and reduce both are existed. We can say that. That is not the LR grammar. So the given grammar is not an LR grammar. Why, sir? At I3, this is I2 and I3. At I3, the at the state, I3 means state, sir. So at state 3, there is a shift action as well as a reduce action. So these two came in one state. So that's why we can say that that is not the LR grammar. So this is the thing, sir. So how can you find the LR grammar or not? So suppose if any item having shift reduce or reduce productions, then we can say that that is not the LR0 grammar. So take one more example, sir. Take one more example. Is the following grammar. So initially we did ambiguity grammar or not. So for in that area also we are getting get questions. One grammar will be given. So and ask, is the given grammar is ambiguous grammar or not? Like that only he will give one grammar and he will ask, is the given grammar is LR0 grammar or not? LR0 grammar or not? So the grammar is E derives E plus N and E derives N, sir. So this is the grammar. Yes, sir. If you want to try, you can try it, sir. Please take two or 3 minutes, because for every grammar we are taking 2 or 3 minutes only. So no need to write the table. You just try to construct. the LR0 items of DFA. With that DFA, you can say that the given grammar is LR0 grammar or not. If any item having shift reduce or reduce conflict, then we can say that the grammar is not an LR grammar. Otherwise, the grammar is LR grammar, sir. Yes, sir. Please take 2 minutes and try to solve it. If anyone get the answer, you please unmute yourself and you can tell the answer. We need more practice, sir, to answer the compiled design questions and the theory of computations like. So it is required to know the subject, that means the concept, algorithm, terminology, definitions, meaning, and all. Along with that, you need practice. You need practice. Yes, sir. Any answers? Any answers? You can try in class, sir, any number of times to check the is the given question is the given answer is right or wrong. But you should not trial in the examination. So that's why it is better to trial here itself. Is there any answer? Okay, good. So again, as usual, the same procedure. So what we have to do? Construct the augmented grammar. So augmented grammar means adding new production. So the new production is E dash derives E. And then E derives E plus N. And E derives En. So this is the augmented grammar. After that, we need to start at start production, that is E dash derives E. We need to put dot. After that, we are having non-terminal. After that, we are having non-terminal. So we need to add these productions or these two productions to the I naught item, because these two are produced by the capital E. So that is the non-terminal. So E derives dot E plus N and E derives dot N. So this is the I naught. This is the I naught. Here, this is the shift operation. This is the shift operation, and this is the go to operation. Sir, how can you say, sir? How can you say, sir? This is also go to. This is also go to. Sir, after dot, if it is the non-terminal, that is the go to action. If after dot, if there is a non-terminal, that is also the go to action. After dot, there is a terminal, that is the shift. After dot, if there is a terminal, that is the shift action. So with that knowledge and with that procedure, I told you. So this is a go to, this is a shift like. So okay, good. Now, if we take first one, so E dash derives E dot. So it is reached to the end. So forget about it. Because it reached to the end. Is it right? Forget about it is right? No, sir. Why? After dot E, from this state, there are two productions. This is one and another is this one. So I naught on E. So these two are there. So these two will move to the same state, not at different states. So we need to write E derives E dot plus R. E dot plus R. So this is the thing, sir. This is the thing we have to write. Now you please check. Is there shift and reduce? Yes, sir. Here it is moved to answer, and here it is after dot there is a terminal, sir. So that is a shift reducer. But that assumption is wrong. Why, sir? This is not the reduction or reduced production. This is the start production. This is the start production. This production is not available in our grammar. So reduce is not correct. This is the accept. This is the accept. This is not the reduce. So this is accept. And this one is shift. This one is shift. Shift and accept is not the problem. Shift and accept is not the problem. So that's why I'm just leaving it. I'm just leaving it. And next, after it is reached to the end and it is reached to the here. Sorry, sir. It is n, not r. It is n. So now on n, it is moving to e derives n dot. Here it is only one production, so no need to check. Now come to here. It is written like this: e derives e plus dot n. After that, there is a shift operation. So and only one production is there. There is no non-terminal to produce to add remaining productions. So e derives e plus n dot. So how many number of operations are there, or how many number of shift type operations are there, how many number of reductions are there? So these are not required, but you need to check how many number of shift operations are there, how many number of reduction operations are there, how many number of accept operations are there, how many number of go to operations are there, like that. You can check. So now our question is, the given grammar is LR0 grammar or not? Yes, it's LR0 grammar because there is no SR conflict or there is no RR conflict. So that's why this is the given grammar is LR0 grammar. The given grammar is LR0 grammar. Is it clear? Yes, sir. Take one more question. So this is the previously asked question, sir. And there is some twist is also there. Which of the following grammar is LR0 grammar? Which of the following grammar is LR0 grammar? Which of the following grammar is LR0 grammar? Option A or option 1? S derives A, S derives small a, and A derives A. And option 2, S derives AS and S derives small a. And option 3, S derives AA or BB, A derives D, and B derives D. A derives D and B derives D. Option 4, none. Option 4, none. So this is the question, sir. This is the question. So we need to check which of the following grammar is LR0 grammar. Which of the following grammar is LR0 grammar? So to make it as augmented grammar, we need to add one symbol, that is S dash derives yes, and here also S dash derives yes, and here also S dash derives yes. So these all are now augmented grammars. So now if we put dot, so here if we put dot here, so S is non-terminal, so we are deriving S dot productions. So S dot productions are A is there, sir. So here A is non-terminal, so we need to produce A. So every production has been added. So this is I naught. Now if you take it, S dash derives S dot. So it's not a problem. It's not a problem. Okay, good. Take it. Next, now if you take this one, S derives A dot. So here also there is no problem. But suppose if you take here, please listen carefully, sir. At this state, this is the I naught state. We are getting after dot A. So A means it must reach to the only one state. Only one state. Here it is S derives A dot and A derives A dot. So again I am telling, sir, this is S derives A and this is A derives A. But here what I am telling is I naught is the state. I naught is the state. And the input symbol is A. In DFA, I have written in the previous example also. In the DFA, we must have exactly one transition with the input alphabet. We must have exactly one transition with every input alphabet. So for that purpose, with A, we need to reach to only one state, not two different states. This A is two separate state. This A is not a separate state. You may confuse. So these two must reach. On A, it has to reach I2, and on A, it is also has to reach I2. So that's why these two are at one state. In this state, there is a problem. This is ended and this is also ended. So the problem is reduce. So this is not a LR0 grammar. This is not the LR0 grammar. So now come to here. S derives, S dash derives, S dot. Okay, good. And here, S on small a, it is reached to the S on small A dot S. Suppose after S we are having, after dot we are having non-terminal. So we need to add these two. S derives dot AS, S derives dot AS, and S derives dot AS and S derives dot A. For this dot after S, we added these two. Now here also this is A and this is A. So they must reach to the same state. That's why this S derives A also reach to this here, this only. S derives A dot. So here A dot is the reduce and dot A is the shift. So that's why, so shift operation and reduce operation is there. This is also shift operation and reduce operation is there. So this is also not an LR0. So these two are not an LR0. So what about this one, sir? What about this one? We will check. So here, if you see here, S derives, this is reached to S dash derives S dot. Okay, good. It is completed. Suppose if you see here, S derives, this is A. So that's why S derives dot. You please take dot. S derives A dot A. So here S on B. So that's why S derives B on B. So this is separate production and this is separate production. So this is I naught, I1, I2. So now if you take these two are after that only same terminal. So must reach to the same state. That's why A derives D dot and B derives D dot. So these two are reduce. So this is also not the LR0. This is also not the LR0. So that's why the answer is None of the above. The answer is none of the above. So I already told you, sir, with the practice only, you can answer this kind of questions. There may be a lot of confusion is there here, sir. Suppose if you take this state is different, this state is different. This state is different, this state is different. This state is different, this state is different. So there is a chance to divert your answer, to take the mistake, indicate. Suppose if you take if you take a wrong answer, wrong choice, there is a penalty. There is a penalty of 1/3 negative marking. So that's why you need take care when answer the questions in the GATE examination. For that purpose, for the comparative design, what I am telling is we are telling the concept. After that, we are taking some model questions. After that, we are solving the previous questions also. So just you need to practice. Just you need to practice. If you do the more practice, so you can easily score from the comparative design subject in the GATE examination. So, sir, without so not only GATE examination, sir. So yeah, you can prove yourself in interviews also. Suppose every programming language must depending upon the compiler only. Suppose they may ask the question, if you want to, or if you are unable to give the answer, you can turn them to you. Sir, how can I turn them, sir? So you can explain the execution order of the program in the compiler. So at that time, they may divert to your answer and they will ask the questions in the compiler. So if you are having good knowledge on compiler, so you can immediately answer the questions. So with this also, you can get the job. So like that, you have to think. So by getting the good knowledge on the subject, it will be very helpful to you in any situations, not only in GATE, not only in competitive examination, not only in interviews, in everywhere. If you are having the knowledge, subject knowledge, it will be helpful to you. So that's why. So please do the practice. It will be very helpful to you, right? So next, there are two more things are there, sir, to find out the LR0 grammar or not. Two more constraints are there. Suppose if any grammar is having the production like this, A derives epsilon. A derives epsilon. Sir, what we have to do? Suppose if any production is there, A derives epsilon. What we have to do? Suppose if you write dot like this, so what it means? You are accepting epsilon. Is there epsilon production in DFA? No, because DFA must have exactly one transition from each and every state with each and every input alphabet. So suppose if you write like this, if you write like this, so that is not the DFA. But many number of times I mentioned our parse table is DFA. So for that purpose, we should not reduce it. We should not reduce it. Sir, what we have to do? Simply, I will give the things and answer for this. Suppose if anywhere, if you see dot epsilon production, if anywhere, if you see dot epsilon production, just replace it. Just listen carefully, sir. Listen carefully. It will be helpful to you. If anywhere, if you see the production like this, A derives dot epsilon, or B derives dot epsilon, S derives dot epsilon, you can replace it with the A derives epsilon dot. A derives epsilon dot. So without accepting that, we have to take it is accepted itself. It is accepted itself. So that is the thing, sir. That is the thing. So suppose if you see an example, S derives A, S, B, S, and S derives B, S, A, S, and S derives epsilon. S derives epsilon. So what we have to do? S derives AS, BS, and S derives BS, AS, and S derives epsilon. What we have to do? So suppose here first we need to add augmented grammar. S dash derives, sir. Yes, sir. So for this, S dash derives dot S. So it is the non-terminal. So we need to add dot AS, BS. Here it is terminal, but it is the non-terminal. We are having two more productions. So for that purpose, dot B, S, AS. So what I told you, sir, suppose if anyway, if you see S derives dot epsilon, we can replace it with S derives epsilon. S derives epsilon dot. S derives epsilon dot. So S derives epsilon dot. Suppose if you see S derives epsilon dot, we can say that is the reduction. We can say that is the reduction. So suppose if you see here, after dot we are having terminal, and after dot we are having terminal. If any production after dot, if there is a terminal, we can say that those are shift actions. And after any, if any production it reaches to the end, we can say that is reduction. So that we can say that there is a shift reduce conflict in the given grammar. So the given grammar is not an LR0 grammar, So in this grammar there is a problem. The problem is SR conflict. So that we can say that there is a SR conflict in the given grammar. So that's why this is not LR0 grammar. So once again I am telling, sir. So initially what I am telling is, if there is a production is in the format of A derives dot epsilon, so then we can say that that is we need to replace it with A derives epsilon dot. So here I replaced S derives dot epsilon. I cannot move, I cannot shift, I cannot move with the go to, because I cannot go another state. Epsilon itself accepted there itself. So that's why here itself it is accepted. Here there is a shift operations and shift actions, and there is a reduction option. So that's why we can say that that is not the LR0 grammar. Okay, one more question, sir. Which of the following grammar is LR0 grammar? Which of the following grammar is LR0 grammar? So the grammars are option A, S derives ASA, option B, BSB. Sorry, sir. Option A only, sir. So the productions are like this. Take it as a homework, sir. So you please try to do this. Suppose if you are unable to get the answer, you please ask. I will explain. So take it as a homework question. Option C. S derives AAB. A derives capital A, small a. A derives epsilon. And option D, none. So please copy it, sir, and try to do at home as a homework question. Which of the following grammar is LR0 grammar? Which of the following grammar is LR0 grammar? So it is not that much easy, I can say that. So, but with the practice only, we can solve the questions, sir. We can solve the questions. So that's why you please try to do it. If you are unable to get the answer, I will explain you. I will explain you in the next class. Don't worry. Okay. Is it completed? Which of the following grammar is LR0 grammar? So S derives ASA, S derives BSB, S derives epsilon. And coming to here, S derives AA, AB, S derives BB, BA, A derives epsilon, B derives epsilon. And here, S derives AAB, A derives AA, A derives epsilon. And D is none of the above, sir. D is the answer is none of the above. So check it at home, sir. Okay. One more thing, sir. One more thing. Sir, already we have discussed the context-free grammar, about context-free grammar. In the context-free grammar, there are two types of grammars are there, sir. So one is ambiguous grammar. Ambiguous grammar. Another one is unambiguous grammar. Unambiguous grammar. So if any ambiguous grammar is not construct the parse tree, if any grammar, if any context-free grammar is ambiguous grammar, it cannot construct the parse tree. So already we decided it because it is undecidable. It is undecidable because there is an ambiguity that is undecidable. So with undecidability, we cannot construct the parse tree. For the unambiguous grammars only, we can construct the parse tree. Okay, good. So in this also, only some of the grammars are LR0 grammars. Only some of the grammars are LR0 grammars. Coming to here, so this is a context-free grammar, and there is no ambiguity here. But it is not the LR0 grammar. So that's why what I'm telling is, even though every non-ambiguous grammar is not an LR0 grammar, I'm going to tell you one more important point, sir. With this point also, you can answer the questions. Please listen carefully. So coming to the context-free grammars, there are two kind of grammars are there. One is ambiguous grammar, another one is unambiguous grammar. Coming to the ambiguous grammars, we cannot construct the parse tree. Coming to the unambiguous grammars, for every unambiguous grammar is not an LR0 grammar. So only some of the unambiguous grammars are LR0 grammars. So we can have non-LR0 grammars in ambiguous grammar as well as unambiguous grammar. Non-ambiguous grammars are in the not ambiguous. These are LR0. Out of these are not LR0 grammar. This is not LR0 grammar. This part is not LR0 grammar. This part is only LR0 grammar. And this total is not an LR0 grammar. So to specify the given grammar is not an LR0 grammar, that may be in ambiguous grammar as well as that may be in non-ambiguous grammar. So that is the thing I am telling. So if you take the question, verify the following grammar is LR grammar or not. Verify the following grammar is LR0 grammar or not. LR0 grammar or not. So suppose if the grammar is S derives AA and A derives small a, and a derives small a. So first sometimes we need to check the given grammar is ambiguous or not. Suppose if I take a is the string. So for that purpose, the LMD and RMD is S derives a and a derives a derives a and a. For in some other case, a so this tree is different and this tree is different. If any string having two different parse trees, the grammar is ambiguous. The grammar is ambiguous. So this grammar is not an LR0 grammar, because any ambiguous grammar is not an LR0 grammar. Any ambiguous grammar is not an LR0 grammar. Sir, we don't know this point, sir. We don't know this point, sir. Sir, how can we say this grammar is not an LR0 grammar with the previous knowledge? So take the augmented grammar. S dash derives yes dot s, and s is deriving a, and again a is deriving a, and a is deriving dot a. With this we can write s dash derives s dot, and with this we can write s derives a dot a. Here it is capital A, that means non-terminal. So we need to add a productions. So a derives dot a and a derives dot a. So here there is no problem. So coming to here, these two are only small a's, and so we need to move to single stater. So for that purpose, a derives small a dot capital A, and a derives dot a dot. So here, is it a reduction? No, it is not a reduction. Why it is not a reduction? It is the non-terminal. So it is not the reduction. But after that, we are having non-terminal. So now the non-terminal productions are again a derives dot a derives dot a. So suppose if you see here, these two are shift actions, and this is reduction action. So shift action and reduction action is there in the given grammar. So then we can say that the grammar is not LR0 grammar. So with this, without checking this one also, by checking the ambiguity, you can say that the given grammar is not an LR0 grammar. Or you can get the questions like this: Is there possibility the ambiguity grammar as a LR grammar? So suppose they want to ask you the theoretically, so they can ask: is the given grammar is ambiguous grammar? Is it a LR0 grammar or not? The question itself they may give. So you simply say the ambiguous grammar is not satisfied the LR0 grammar property. So that's why the ambiguous grammar is not an LR0 grammar. So you can write it, sir. So these are the things. So to check the LR0 items, we have discussed how to construct a LR0 parser. We have parsing table. We have discussed how LR0 parsing algorithm works. We have discussed, and how to check the given grammar is LR0 grammar or not. We have checked it, sir. So here there is a small disadvantage in the LR grammar or LR0 grammar. There is a LR0 parse table or parsing table. There is a small drawback. What is that drawback? If you are having any reduction operation, that reduction operation is filled with all the terminals. If there is a terminal with 4 terminals, you are placing the reduction operation all the 4 non-terminal, all the 4 terminals. So the reduction operations are more here. The reduction operations are more here. So that is the disadvantage. That is the disadvantage here. So why these many reductions we are writing? Because here push here name itself there is a 0. Here the name itself there is a 0. That means no look ahead symbol. There is no look ahead symbol. So look ahead symbols are 0. That's why we are not considering how many number of reductions we are placing. So that is the problem. Sir, how can we overcome this one? With SLR1, we can overcome it. With SLR1, we can overcome it, sir. So this is the drawback. What is the drawback here? So number of reduction operations are more. Why number of reduction operations are there? So because here there is no look ahead symbol. So how can we overcome this one? So with the SLR1, we can overcome this one. So in the next week, I will start with SLR1, sir. So for this week, we have discussed about shift reduce parsing. So bottom up parsing algorithms. Coming to the bottom up parsing algorithms, we have discussed about shift reduce parsing and LR0 parsing. So with this, what is LR0 parsing? What is LR0 grammars? What are LR0 items? How LR0 items are recognized with the closure and go to? So what is augmented grammar? So is the given grammar is having epsilon production? How we need to use go to or closure? So and if the given grammar is ambiguous grammar, so can we say that grammar is LR0 grammar or not? So like that we have discussed it, sir. Before that we have checked how many number of shift actions are performing, how many number of reduction operations are performing, how many number of shift operations are performing, and how many number of reduction operations are performing. So you may get the questions like LR0 items, how many number of LR0 items like, or how many number of shift actions and how many number of reduce actions, or how many number of go to actions and how many number of accept actions. So you may get the question. So by giving the grammar and the table and the string, sir, without giving all these also, so he can ask next. So the given grammar is next one, LR0 grammar or not. The given grammar is LR0 grammar or not, and how to accept the string with the LR0 parsing algorithm. LR0 parsing algorithm, how we are telling the acceptancy. So these are the things we discussed in this picture. So this is a more important concept, and as well as this is the continuously depending concept. So please don't forget that and don't miss the classes. So it will be more helpful to you. So I already told you 60% of the GATE syllabus is bottom up parsing, or bottom up parsing and top down parsing. Parsing is the 60% of the syllabus will be covered with bottom up parsing and top down parsing. So this is the more number of questions you may get. So in this area. So and this is the totally dependency. Initially we discussed about shift reduce. In shift reduce there is a problem. What is the problem? There is a shift reduce or reduce problem, a conflict came. So for overcome that problem, so we are moved to the LR0. So with LR0 there are also we are getting the same problem, but most of the cases we overcome those by finding the LR0 items. So those parse table or LR0 parse table having shift reduce or reduce, those are not LR0 grammars. Those are not LR0 grammars. So we discussed about it. So this is the thing, sir. If anyone are having doubts from this class or yesterday's class, you can ask. If anyone are having doubts from yesterday's class and today's class, you can ask, sir. No doubts? Okay, sir. In the next week, I will start with the SLR1 parsing. So how we will overcome the problems which came in LR0 parsing. So I will discuss in the next class. Thank you.